According to the 2020 National Electrical Code, the main electrical panel can be used as a junction box for correcting double-tap breakers under certain conditions. Firstly, the panel board has sufficient space to accommodate the additional conductors and devices. This means that after the splices and any other necessary components are installed, the panel still meets the code requirements for wire fill. Careful calculation is key. Secondly, the panel board is accessible for maintenance and troubleshooting. The panel must be easily accessible for future work without obstruction. Thirdly, the splices are made in accordance with the NEC. This involves using approved methods such as wire nuts or terminal blocks, ensuring proper connections, and insulating the splices effectively. Fourthly, the splices are protected from physical damage. Wires and connections must be properly secured and protected from any potential physical damage that could compromise their integrity. If these conditions are met, then it is permissible to use the main panel as a junction box to correct double-tap breakers. It is essential to verify that your specific installation meets all of these requirements to comply with the NEC. It is important to note that some local jurisdictions may have additional requirements or restrictions, so it is always best to consult with the local authorities before proceeding. Local amendments to the NEC or specific interpretations by the authority having jurisdiction or OJ can further influence the permissibility of this practice. Always check with your local building department or electrical inspector to ensure compliance with all applicable codes and regulations in your area. Using an external junction box for correcting double-tap breakers is also an option. This is done even if the main panel has sufficient space. There are several potential benefits to using an external junction box. Firstly, an external junction box is more accessible for maintenance and troubleshooting. Separating the splices into a dedicated box can make it easier to access and work on them without disturbing the main panel wiring. Secondly, it can provide better protection for the splices. An external junction box provides a dedicated enclosure for the splices, protecting them from dust, moisture, and physical damage. Thirdly, it can simplify future modifications. If changes or additions are needed in the future, an external junction box can provide a convenient point for making those modifications without having to work within the confines of the main panel. Ultimately, the decision of whether to use the main panel or an external junction box is up to the electrician. Factors to consider include the available space in the panel, the accessibility of the panel, the complexity of the wiring, and the preferences of the electrician. It is important to carefully weigh the pros and cons of each approach before making a decision. When calculating the available space within the panel, several factors need consideration. Firstly, the volume of the conductors. The NEC specifies how to calculate the volume occupied by conductors of different sizes. This calculation is based on the number and size of the conductors entering the box. Secondly, the volume of the devices such as splices, wire connectors, and grounding conductors. These devices also take up space within the box, and their volume needs to be accounted for. Thirdly, the working space around the panel. The NEC requires adequate working space around electrical panels for safety and accessibility. This working space needs to be maintained even if the panel is being used as a junction box. When making splices within the panel, it is essential to follow the NEC requirements for splicing and terminations. Firstly, use approved methods. Only use splicing methods and connectors that are approved for the specific application. This includes wire nuts, terminal blocks, and other approved connectors. Secondly, ensure proper connections. Make sure that all connections are tight and secure. Loose connections can cause overheating and arcing. Thirdly, insulate the splices effectively. All splices need to be properly insulated to prevent shorts and ground faults. When protecting the splices from physical damage, several measures can be taken. Firstly, secure the wires properly. Use cable ties or other means to secure the wires within the panel and prevent them from being damaged. Secondly, protect the splices from sharp edges. Make sure that the splices are not exposed to any sharp edges or other hazards that could damage them. Thirdly, use a suitable enclosure. If the splices are exposed to a harsh environment, consider using a suitable enclosure to protect them. It is important to understand that using a main panel as a junction box can create potential challenges. Firstly, overcrowding can be a challenge. If the panel is already crowded with wires and devices, adding more splices can make it difficult to work on the panel. Secondly, heat buildup can be a challenge. Splices can generate heat, and if the panel is not properly ventilated, this heat can build up and cause problems. Thirdly, accessibility can be a challenge. If the splices are located in a hard-to-reach area of the panel, it can be difficult to access them for maintenance and troubleshooting. When considering the accessibility of the panel, ensure that the working space around the panel meets the NEC requirement. This working space needs to be clear and unobstructed, allowing electricians to safely and easily access the panel. Additionally, the panel should be located in an area that is well lit and free from hazards. Consulting with local authorities is essential to ensure compliance with all applicable codes and regulations. Local building departments and electrical inspectors can provide guidance on specific requirements in your area. They can also help you to interpret the NEC and other applicable codes. Remember that the NEC is a minimum standard, and local jurisdictions may have more stringent requirements. Always check with the local authorities before proceeding with any electrical work. If you are not comfortable working with electrical wiring, it is always best to hire a qualified electrician. Electricians have the training and experience necessary to safely and properly install electrical wiring. They can also ensure that your installation complies with all applicable codes and regulations. Working with electricity can be dangerous, and it is important to take all necessary precautions. Always turn off the power before working on any electrical wiring. Use appropriate safety gear such as insulated gloves and safety glasses. If you are not sure how to do something, ask a qualified electrician for help. Electrical panels should be properly labeled to identify the circuits they serve. This helps to prevent accidental disconnection of important circuits. Use a circuit directory to clearly label each breaker in the panel. Update the directory whenever changes are made to the electrical system. Grounding is an important safety feature that helps to protect against electrical shock. Ensure that the electrical panel is properly grounded according to the NEC requirements. Check the grounding connections periodically to make sure they are tight and secure. Arc fault circuit interrupters, or size, are designed to protect against arc faults, which can cause fires. The NEC requires of size in many areas of the home, such as bedrooms. Consider installing a size to provide additional protection against electrical fires. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electrical shock. The NEC requires GFCIs in many areas of a home, such as bathrooms and kitchens. Consider installing GFCIs to provide additional protection against electrical shock. Surge protection devices, or SPDs, are designed to protect against voltage surges, which can damage electronic equipment. Consider installing SPD to protect your electronic equipment from power surges. The electrical panel should be inspected periodically to ensure they are in good condition. Look for signs of damage, such as corrosion, overheating, or loose connections. If you find any damage, have it repaired by a qualified electrician. The electrical panel should be kept clean and free from dust and debris. Dust and debris can accumulate inside the panel and cause overheating. Clean the panel periodically with a vacuum cleaner or a soft brush. Never use water or other liquids to clean the panel. Electrical panels should be accessible at all times. Do not block the panel with furniture or other objects. Make sure that there is enough clear space around the panel for an electrician to work safely. Electrical panels should be properly ventilated to prevent overheating. Make sure that the panel is not blocked by insulation or other materials that could restrict airflow. If the panel is located in a confined space, consider installing a ventilation fan. The size of the conductors used for electrical wiring is determined by the ampacity of the circuit. The ampacity of a conductor is the maximum amount of current that it can safely carry. The NEC specifies the ampacity of different sizes of conductors. The type of insulation used on electrical wiring is also important. The insulation helps to protect the conductors from damage and prevents electrical shock. The NEC specifies the types of insulation that are allowed for different applications. The color coding of electrical wiring is used to identify the different conductors in a circuit. The NEC specifies the color coding for electrical wiring. For example, black wire is typically used for the hot conductor, white wire is typically used for the neutral conductor, and green wire is typically used for the grounding conductor. Electrical boxes are used to enclose electrical connections and protect them from damage. The NEC specifies the types of electrical boxes that are allowed for different applications. Electrical boxes should be properly grounded to prevent electrical shock. Conduit is used to protect electrical wiring from damage and moisture. The NEC specifies the types of conduit that are allowed for different applications. Conduit should be properly supported and secured to prevent it from sagging or breaking. Cable ties are used to bundle and secure electrical wiring. Cable ties should be made of a non-conductive material and should be properly tightened to prevent the wiring from coming loose. Wire connectors are used to connect electrical wires together. The NEC specifies the types of wire connectors that are allowed for different applications. Wire connectors should be properly sized for the wires they are connecting and should be properly tightened to ensure a secure connection. Electrical tape is used to insulate electrical connections and protect them from moisture. Electrical tape should be made of a non-conductive material and should be properly applied to ensure a tight seal. The NEC contains many tables that provide information on electrical wiring. For example, Table 310.16 provides information on the ampacity of conductors. Table 310.15b16 gives the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in conduit or cable or directly buried in earth, based on ambient temperature of 30 degrees Celsius. These tables are essential for safely and properly installing electrical wiring. Understanding basic electrical concepts is essential for working with electricity safely and effectively. These concepts include voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical current. Power is the rate at which electrical energy is used. Ohm's law is a fundamental law of electricity that relates voltage, current, and resistance. Ohm's law states that voltage is equal to current times resistance, or volts equals amps times ohms. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Watt's law is another fundamental law of electricity that relates power, voltage, and current. Watt's law states that power is equal to voltage times current, or watts equals volts times amps. This law can be used to calculate the power, voltage, or current in a circuit if the other two values are known. Series circuits and parallel circuits are two basic types of electrical circuits. In a series circuit, the components are connected in a single path. In a parallel circuit, the components are connected in multiple paths. The voltage, current, and resistance in a series circuit are different from the voltage, current, and resistance in a parallel circuit. Understanding the differences between series circuits and parallel circuits is essential for troubleshooting electrical problems. Electrical safety is paramount when working with electricity. Always take necessary precautions to prevent electrical shock and fire. Turn off the power before working on any electrical wiring. Use appropriate safety gear, such as insulated gloves and safety glasses. If you are not sure how to do something, ask a qualified electrician for help. Regular maintenance of electrical systems can help to prevent problems and extend the life of the system. Inspect electrical panels periodically for signs of damage. Check the wiring for loose connections or frayed insulation. Replace any damaged components immediately. Have the electrical system inspected by a qualified electrician every few years.